Hello students, welcome to problem set number 5. From this problem set there will be a different format. There will be more number of questions but more direct and broken down. And therefore the clues necessary to do these problems will be minimum. Look at number 1. Convert 100 Celsius to Fahrenheit and Kelvin. All you got to do is use the formula. You want it in Fahrenheit, and so whatever you're given in Celsius, plug it in here, use this formula and find the answer. And then to change it to Kelvin, you just have to add 273.15 to the 100 Celsius. Number 2, now you have to convert from Fahrenheit to Celsius. So look at the difference. It's 5/9 instead of 9/5. But another big difference is that you have to first subtract 32 from what is given. So 0 minus 32. Yes, and you're going to get a negative 32 there. Then multiply it by 5, divide by 9. And then to change into Kelvin, whatever answer you get for the Celsius, to that add 273.15 like we did for question 1. Now question 3 is the same, so I'm not going to talk about that. So the first 3 questions are to do with change from one scale to another. But question 4 talks about expansion of a steel rod. The original length is given, which is L, and the change in temperature is 80. So that's delta T. 100 minus 20, that's 80. So you have these two. And then the constant for steel, the coefficient of linear expansion for steel, which is alpha, is also given. So all you got to do is multiply those 3 to get the answer. And the answer is going to be in meters because the original length is in meters. Number 5 is a similar question. Oh, I'm sorry for all of these things here. So let me read it. A brass plate has an initial area of 1.5 meters square. That's all you need. So you don't need all the stuff. Cross it out. So the initial area is given, which is 1.5 meters square. And at 25 degrees Celsius. So you don't need this also. The plate is heated to 200 Celsius. So which means now you know the change in temperature is 200 minus 25. That's the delta T. The plate, the alpha is given again, but since we are trying to find the change in area, you got to multiply alpha with 2. So that's why you have 2 alpha. Similarly, if we were trying to find the change in volume, then it should have been multiplied with 3. Keep that in mind. So then multiply those 3 quantities and you get the answer. Number 6 is straightforward. You're given the mass, you're given the volume, and you're asked to find the density. Density is mass divided by volume. You can keep this in grams and keep this in centimeter cube. So the answer would be in grams per centimeter cube. Number 7 is similar, except that although you're using the same formula, you're asked to calculate the mass. So there's a little bit of algebra there, one more step, okay? You're going to get the mass in grams. 8 is different. Calculate the amount of heat required to raise the temperature of 500 grams of water. So you're given the mass in grams, from 20 to 80. So you have the change in temperature, which is 60. So you have that, you have that. The specific heat capacity of water is 4.18. Look at the units. Joule per gram Celsius. That means you can have mass in grams because this is in grams. All you got to do is multiply those three quantities and you get the answer in joules. Number 9. Similar question. Same question. Except you got to notice this time the mass is in kilograms. The constant is still in grams. So what you got to do is change the 2 kilograms into grams. That would be 2,000 grams. Because 1 kilogram is 1,000 grams. So that's the only difference. In place of 2 kilogram, you're going to use 2,000 grams. Okay? 10. Same. But this time, you are calculating the constant C. Same formula. Again, this is in joules, this is in grams, so you're going to get the constant in joule per gram Celsius, just like that. Same formula. Just use that same formula here. The 11th question has 2 parts. If you read it, you see a 500 gram block of ice at negative 10 degrees Celsius is heated until it completely melts and reaches 0 degrees Celsius. So why are there 2 parts? Because when you start heating ice at this temperature, it will not melt. First, it has to reach 0 degrees Celsius. So that's why you have this first part here. Ice at negative 10 Celsius has to be heated to 0 Celsius. And the formula used for that is what we've been using many times. That is mass times specific heat of ice, which is given there, times change in temperature. Once ice reaches 0 degrees Celsius, it begins to melt. So to find the heat required to melt it, you have to use this formula. Q is mass times latent heat, and that's given. So always remember that whenever there is a change of phase, like melting or water boiling and becoming steam, in all these cases of phase changes, you have to use this special formula. But if it's normal heating or cooling, then you would use this formula. 12. This is conduction of heat. So here we're talking about heat being transferred from one end of a metal rod to the other end. It's like if you heat one end of the rod, after some time, the other end will also become hot, wouldn't it? This is called conduction. And you're asked to find the rate of transfer of heat through the rod. So you're asked to find Q over T. Now, little t is time. So you're finding how many joules go across the rod in 1 second. That's what you're finding. So for that, you need K, which is a constant. It's called thermal conductivity. It's given. Area of the rod, that's the area of cross section. You know, like if a rod is like that. Oh, come on. If the rod is like that, this is the area of cross section. It's circular. But now you don't have to worry, it's given. Directly given. So that's the A. Now change in temperature is the temperature difference between the hot and the cold ends. So that's 70 degrees Celsius. D is the length of the rod, which is 1.5 meters. So you got all those quantities and you have to just do the math. 13, similar question. So I don't have to talk about that. This is rate of heat conduction through a wall. So you're given the area once again. You have the D there. You have the temperature difference. You have the constant. Okay. 14 brings us to radiation. Now, in this formula, you have to remember that T sub S is the temperature of the surrounding. If nothing is mentioned about the surrounding, you take it as 0 Kelvin. Okay, so in this case, you always have to have the temperature in Kelvin. Remember that. Whenever this formula is used, temperature has to be in Kelvin. Now, the area in the formula is the surface area, which is given, because it's a steel plate. You know what a steel plate is, don't you? So you have to take the area of the whole surface like this. See the area. That's given. And then sigma is a constant. It's called Stefan-Boltzmann constant. That's given here. E is called emissivity, and that's given. So you got sigma, you got E, you got A, and T sub H is the temperature in Kelvin, which is also given. Do not forget that since there's no mention of the surrounding, this is 0. Okay. Now 15 is a similar question, except the wording. Here it says calculate the rate of heat. Here it says calculate the power. Both are the same, because energy by time is power. Heat by time. Heat is a form of energy. So that's the only difference. Everything else is the same. So I hope you're able to plug it in and get the answers to all of these questions. For sure, it's going to take some effort. It's going to take some focus. You got to be focused when you're doing math. Try always to have units with each quantity. So don't just put the number. Put the number and the unit, especially for the answers. And I hope this makes sense. We'll see you on the next one. Thank you.